Hello, now we are going to talk about the angle between a line and a plane. So you have a plane here, and then there's some line that's going through the plane, and then you're going to see and we're going to let this, if we let this vector u be on line L, and then alpha will be the angle between the normal vector, right? Since this is the normal vector that's perpendicular to the plane, and then this uh, vector that goes through it, and this theta is the one we're going to try to find out what that's equal to. That's the angle between the plane and the actual line, right? But to be able to find that first, it's going to be a little bit, so we don't know any vector that's in the plane. We know the vector, we're going to just use the vector of the line that's going through it, and that's what we want to find out, right? So, but we can find the alpha, right? We know that the cosine of alpha, right, is going to be equal to the dot product between the normal and the vector going through it over the magnitude, right, of the normal line and the vector that's going on the line, right? Now, we want to be able to solve this, though, for the angle of theta between the line and the plane, not the normal vector. So, but if you notice this normal vector is 90 degrees. So isn't alpha going to be equal to the cosine of pi over 2, or 90 degrees if you want, minus theta, right? That's going to be equal to that. And then this is an identity, right? This can be, since this happens, I know that this is equal to the sine of theta, which is going to be equal to the normal vector dot product, the vector of the line, the vector that's in the line, going through the plane, and then over the magnitude, right, of the normal vector over the magnitude of the vector u, right? And then I can solve for theta, right? And after I do that, I get this this rule right here, right? And this is the angle between, when I solve for this, for the sine, the arc sine, or the sine inverse, I could say the angle theta between the line parallel to u and the plane with the normal vector n is given by theta is equal to the arc sine. It has to be the absolute value because, look, we want to, this is between 90 degrees, so we don't want this value coming out to be a negative number, so it's posited out, make sure it's acute, right? And then between 0 and 90 degrees. Alternatively, you could use this formula too, right? You could have just found the cosine of that angle, right? And then to find this one, you have to take 90 minus this. So this right here gives you gives you alpha, right? This guy right here would be this would be angle alpha, right? So 90 minus that gives you this angle theta right here. So you can use that. Maybe you want to use that so you don't have to remember the sign since it's different. It might be easier for you to just remember, well, just know you're not finding the angle between the line and this, you're finding the angle between the normal vector when you do it this way. But then if you minus 90 degrees minus that angle, then you're going to get that angle theta. Sound good? So let's go ahead and use this in an example. So let's look at, hold on a second. All right, here's example 42, and it says calculate the angle between the vector equation r, where it's 3 minus lambda I plus j plus -1 plus lambda k, right? And then in the plane with the Cartesian equation x minus 3y plus z equals 1. So the first thing, this vector equation right here, if you notice, r can be written as 3, 1, -1 times plus lambda, and it's going to be -1, 0, 2, right? So the vector in this line right here, u, is going to be -1, 0, 2, right? And then from the Cartesian equation, the normal vector are the coefficients of this equation. So I know the normal vector to that is going to be equal to 1, -3, 1. And then I can find the angle between that by taking theta is going to be equal to the sine inverse of the absolute value of the magnitude between the normal and this. So this would be -1 plus 0 plus 2 all over the magnitude of this. This would be 5 times the magnitude 11. Good. And then I can go ahead and use the calculator to calculate this. And then I can go sine inverse, and it's going to be the absolute value of the, I'll take, looks like this top one's just going to be 1, and then it looks like root 55, right? And then there you go, and then that gives me theta is approximately equal to 7.7, pretty much 7.75 degrees. And there you go. Thanks, guys.